All right, so a few minutes late, but better late than never. I'm sure this is interesting. I've never done a 9 o'clock at night presentation, but I guess the good news is I'm not actually the one presentation between you and going to the casino, so to speak. So welcome. We're going to talk about generative AI and security with generative AI here in the next, now 25 minutes or so. So my name's Dave Kliemann. I'm a cloud risk and controls leader. I'm part of the IBM and specifically the IBM Cloud team. Although I will give the proverbial all opinions expressed during this particular session are mine. They are not related to IBM specific or anything like that. I've been part of IBM for a few years. Before that, I was over at Fiserv in various cybersecurity roles for a number of years. Before that, I was a naval officer for 20 years. More pertinent to this particular topic was I got involved in cybersecurity, including heading the Navy Cyber Red Team for my last role. And in my spare time, I'm actually an adjunct over at Marquette. I help teach a cybersecurity class. So for this evening, I was asked, what do you want to talk about when it comes to AI? There have been a number of great presentations for different things already. I want to actually take us back a little bit and let's think about it from a foundational aspect, because when we're trying to talk about how are we going to secure AI, how are we going to break into AI, what is it that we need to do? Let's think about it. What is AI? What's its purpose? What is it actually trying to accomplish? And the bottom line is, this is just an outcropping of how do we actually understand data, and what's the story that data is trying to tell us. And if you go from the the 80s, when the first big data sets were starting to become available, to into the 2010s, really what we've seen is this massive explosion in the raw data that exists, that's out there. And what we've really seen when we start talking about this newest thing, this generative AI, the latest iteration in AI, is we're trying to take this from a technological standpoint. We are going from having structured data, labeled data that you are trying to do some sort of big data analytics on, to now you have massive amounts of unlabeled data, unstructured data, and the computer, the system, is actually learning and doing a self-supervision as part of its machine learning at scale. And that's what, when you hear people talk about ChatGPT, when you hear people talk about large language models, LLMs, even more, that's just a type of foundation model. There are other foundation models than just LLMs. For example, IBM has actually partnered with NASA for some geospatial foundation model. In the healthcare industry, there's a number of foundation models that are being built around how can the human body, how you can discover diseases based on types of scans. So when you hear things in the news about this AI was 40% more effective at detecting breast cancer than person, that comes from foundation models. And what foundation models really encounter is you have this model that you've pre-trained on data that's not structured and not labeled. In fact, it's funny, and I've been dealing in the cybersecurity industry between the financial sectors primarily and the Navy for over 15 years now, and we've actually had a type of artificial intelligence and machine learning. It's been in the cybersecurity industry. There have been a number of tools. You've got all these cybersecurity vendors that have been touting AI. They've moved beyond signature-based, the heuristics. Well, that's a form of AI. But the way those models for pick a security vendor came about is they were trained on labeled training data. The quickest example I would give is if you have using a tool that was designed to detect phishing emails, if it's part of your email system. Well, what they did is they gave the model, here's what phishing emails are, and here's some non-phishing emails. So the model could try to learn on that. But the beauty of foundation models is you don't have to do specific labeling of the data that you have. That doesn't mean you don't need to train and tune models, and you hear this term about prompting and inferencing, which we'll get to in a little bit. But the bottom line is those are ways you can make your responses more accurate, and that's a direction. Whether you're talking, with any of these new large language models, foundation models out there, Microsoft with Copilot, OpenAI, IBM with our Watson X solution that you're going through, and what it's doing is it's allowing you to have more use cases that you can use that base model as your foundation for what you're trying to accomplish from a business standpoint. Now, when it comes to the models themselves and AI and generative AI, what we're talking about, some of the risks that we are dealing with are kind of the same risks that we've dealt with any type of big data analytics. They're not always predictive. Sometimes they're actually very bad at being predictive. You have a hard time, that it's the old garbage in, garbage out when we talk about fairness and equity. In the financial sector, for example, there have been certain test use cases about, well, have AI decide if you're going to give a mortgage or a car loan to someone. Well, if your historic data as to who you gave car loans to had some biases built in, then those biases actually come in. So you have to take that into account. But foundation models also have some new model risks that you have to take into account. I'm sure most everybody has heard about hallucination and this lack of factuality. I'm going to say this right now to make it clear. Don't use a large language model. Don't use generative AI as Google. It's not, if you're just trying to look up a fact, use Google or use something, Bing or whatever search engine you want to use as your search engine of choice. Don't use a large language model. Now, if you want to do a search and then you want the AI model to do something about it, that's where it might be a better use case, that you'd be using generative AI, using these large language models to actually do something with that. But so there's a whole new list of model risks that we have to account for when we're talking about a generative AI and what we're dealing with. And let's look at a few though. So here's an example of one. This is a hallucination. So the green is what we highlighted is what the model the AI returned. There was asked, when did France gift the Lithuania Vilnius TV tower? Well, the answer actually is never. And it certainly didn't happen after the Soviet Union dissolved, because it actually was put up in 1980. So one of the things that we've actually seen, when we talk about the hallucinations and why they occur, for whatever reason, large language models have, and it's not just one, but they have this tendency that if you ask it a question, it wants to give you an answer. And the answer is, in some ways, it's not that different than people. People don't like saying, well, I don't know what the answer is. So people will make up an answer. Well, actually, that's what large language models, even though they do it differently, they kind of end up doing something very similar in that particular perspective. Another challenge you have to deal with is this concept of prompt injection. So we went back to that earlier slide where it was talking about this zero prompt or couple of shot prompts. It's one of the ways that if you are building out an application, you're trying to leverage generative AI and large language models to solve your business problem. Whether you're a developer, you're in the business, you can actually give it instructions, and this particular case is it's, put things into the proper grammar of English, and by the way, don't use any vulgar language, hate or profanity is what we refer to it. And so it gives the example in blue on top. That's the way it's functioning normally. But prompt injection is the next time you put some input into the model is you can basically say, oh yeah, ignore those instructions. So try that one for your capture the flag. Tell it to ignore the instructions. And see what it'll do there. And sometimes it'll do that if you haven't put the proper controls around what you're actually trying to do in terms of what you're going to allow that model to return in terms of a response. The other challenge when it comes to that is, and you don't have to actually directly do that prompt into the model. Next slide, I'm going to show a graphic talking about what an actual AI application stack looks like. But the reality is, especially like if you're just going online to OpenAI, to ChatGPT, or most of the ways that you're actually interacting with that large language model, you're not directly providing that input. So there's a possibility of an indirect prompt injection. In this particular case, the example is basically trying to use, for example, the email system or the web browser, since that's the way that we're accessing a lot of these large language models. You're accessing, it's cloud, they're all cloud-based accesses and so forth. So you not only have to worry about the direct input into your LLM, your foundation model, but you have to worry about, well, what are those applications that are actually feeding in, both putting prompts in, putting data in potentially, and pulling data out based on what that large language model response is. And so when we talk about how do we protect our AI applications, how do we protect our AI use cases? Again, I spend most of my time dealing with the financial sector. Even now at IBM, we have clients who are dealing with tons of sensitive information. All of your PII, your private information, your bank account information, all of that type of information that you really, really want to protect if you're a financial institution or you're a service provider for a financial institution. And so, I actually do this with my class that I teach at Marquette. I structure it around the NIST cybersecurity framework because the bottom line is, I'm a big believer, you have to start with a holistic framework approach, because inevitably, if you don't have a holistic framework approach, then what you're going to get is you're going to get this vendor. It's going to come up and they're going to have the magic tool that's going to solve your problem. Doesn't matter what it is. If it's a cybersecurity problem, if it's a technology problem, they're going to have the magic tool that's going to solve your problem. And people in your organization, and I've encountered this personally, oh, well, we bought tool X, so therefore we do cybersecurity, or we do this, or we do that. No, we have a tool that helps us do it. And so in order to take a holistic approach, one of the things you have to start with is the technology stack. And as you can see here, that's what's on the left-hand side. The reality is most people, and most of you, whether you're doing it just kind of as a side project, or whether it's in your place of employment, your organization, you're only going to be working at that top level. That's what you're working at with those apps. And you get within those AI applications, that's what's embedded. So when we talk about, like Copilot is embedded into everything that Microsoft is doing with Microsoft 365. From the IBM perspective, we have a number of tools like Watson Assistant and Watson Orchestrate and Watson Code Assistant. Those are working at the top level, that top layer there. Sure, you need to worry about what are the risks associated at that layer. But if you're actually trying to create a solution, something that is going to solve a business problem, and you're trying to do it in a safe and secure manner, you have to think about what are those risks all the way through that stack, all the way to your infrastructure layer. which most of these solutions, again, it's in the cloud. That is where you're accessing it. And then when you look at those risks, now you're going to take that into it. Now what you can do is you can develop controls based on that entire stack. Think about each layer. What are the risks? And associated with those risks, how do you mitigate those particular risks? And what that'll end up doing is that'll end up creating a scenario where you can create an entire life cycle of governance around your AI solution, your AI use cases that you're going to do. And they go from everything from dealing with that model, the model risk, the model life cycle, which I'm going to talk about here in a second, to a continuous monitoring of what you're doing and to make sure that things don't go off the rails. You know, for those who are in cybersecurity, you know, how many of us, we all know that no matter how securely you design and deploy some piece of technology, inevitably, as you're operating it, you're going to end up with drift. Things are going to change. Something's going to come up. Maybe there's going to be a new threat. Some new vulnerability comes up that you didn't even think about because it didn't exist a year ago when you deployed it. And so that's what you have to think about. And when we talk about foundation models, one of the key parts, there's a life cycle that you can use in terms of how do you actually keep the model itself secure. So now we're talking at that model layer. We've had the whole layer of the stack. There's applications, the AI engine itself, but also the model. And unfortunately, I don't have time, especially since we started late. I can't go through all of the different steps here of the model lifecycle. But the bottom line is you have to think about it from everything from the initial thought of someone in your organization says, hey, I want to use GenAI. Well, why do you want to use it? What's the use case? Does it make sense? Well, okay, what model makes sense? How do we develop that model? How do we validate? For all the talk, and IBM's CEO has been all over the news for the last year talking about how like 40% of repetitive tasks are things that can be automated using generative AI. That doesn't mean you can automatically trust what the AI is going to spit out. Go back to those hallucinations. Inevitably, we are going to see it come up with the wrong answers. So you actually have to do validation testing, QA. You have to make sure that the answers it gives actually are a result. If you want a perfect example of what the consequences of that could be, a couple months ago, there was actually a court case. Canada Airlines, they had updated their chatbot, their AI. Someone had asked the chatbot that if I do this, they basically had to cancel a flight because they had a family member pass away. They asked the chatbot if they would get reimbursed. The chatbot said yes, even though that actually wasn't Canada Airlines policy. And so that person took Canada Airlines to court, and the court said, yep, the chatbot, they were going off the information from the chatbot. It was the same as if a live person had told them. So you have to be able to validate those. Otherwise, you're potentially putting your organization at risk. Now, even once you do those type of validations, you have to think about, well, how do I actually know this? And you have to kind of collect it, and we refer to that as facts. Facts about why you're using this model, what's the purpose that you're using AI, to your data scientists for what data is being used, to people who actually did the model validation, to the engineers who are deploying and operating. And unfortunately, all of these things can tend to get jumbled together, and it just becomes a real mess. And how do you actually know what you have? And at IBM, we refer to them as fact sheets. In fact, we actually like to liken it to a nutrition label. When you think about food, it has a nutrition label. It says this is what actually exists inside that package of food that you're buying. Well, that's what we advocate for in terms of when you're using a generative AI, you want to create that exact same thing via a fact sheet in terms of so that you can know everything there is about your particular AI use case, the model that was used, the data that was used, and so forth. Now, if you want, you can, a couple of resources here that you can use. So one is, so for those that are familiar with the MITRE attack concept, that MITRE attack framework, this is how a threat actor can go after, your technology, whatever that is. MITRE has come out with an AI version of this called MITRE Atlas. So you can just Google it. You go to the MITRE website, and what it's focused on is these are a set of risks based on an attacker perspective of how they might particularly attack an AI machine learning tool set. So, it's free to download. There's different formats you can use it for. So this is one way that you could do. Another thing, if you're actually involved in the development of AI applications and the usage of AI models, you can go to OWASP. OWASP has a top 10 for large language models. These are the risks that you have to take into account. These are some controls that you can think about, or ways that you can try to mitigate those particular risks. So again, super easy. You can just Google AI top 10 or OWASP top 10 for LLMs, and you can have access to it. So just to kind of summarize for the way, talking about this, if you think about it from a mindset of securing your data, securing your model, securing your use case, and oh, by the way, all those same cybersecurity things that you had to think about, whether you have an on-premise environment, you're in the cloud, whatever other technology you're using within your organization, all of that still exists. You have to if you don't deploy it on a secure infrastructure, then it doesn't matter. You're still at risk of having some of those AI controls be an issue. So the last thing, based on the time that I have left, so I do have some resource links. So this will go to the CypherCon, so they'll have that. The QR code is specifically designed for anybody that's involved in the financial sector. IBM, we have a site called Tech Exchange. We have a financial services forum where this is all free, lots of information. When you look at those links on the left-hand side, there's a lot of great information. Again, there's the links to MITRE, Atlas, OWASP Top 10, and so forth. And that's... So I probably have about 1 or 2 more minutes. I could answer any questions that might come up. All right. Well, thank you very much.